So a couple of tools that we use to really help define project scope, that is interpreted from the problem statement and the project charter, would be the Pareto Chart and the SIPOC. Now a Pareto chart just really helps us to assist the narrow of the scope, especially during the project, by identifying the causes that have a major impact on the project. What a SIPOC is just a map that's a high-level process map that helps all team members to understand the process function at the supplier, input, process, output, and customer level. One other tool that we use in the define phase is process maps. And a process map is a micro-level flowchart that provides an in-depth detail of a process. The map also covers details at all levels and provides a walkthrough of the current process experience. Now there are a few different types of maps. The first one, as discussed previously, is the SIPOC map, which is used as a blueprint while drawing our initial level 1 process map. Now a level 1 process map provides in-depth information of our current process, but the final process map will drill down even further into detail. So the first map that we want to create is a SIPOC. It's a great way for us to start getting our blood pumping and figuring out what our level 1 is. Now the level 1 process map, again, is just our first round process map generation. When we have our final current state process map, that's a revisit to it to make sure that we didn't miss any process steps or any data information that needs to be located there. Project metrics are the fundamental elements required for measuring a project's progress. They are developed in the define phase. However, they are not finalized until the measure phase of our project. And there's two types of metrics that we look at. The first one is our primary project metrics, which would be our supplies or internal processes, and customers, which are sources that provide the primary metric for the project. So some examples might be quality, cycle time, cost, value, or labor. The other type of project metric that we look at is a secondary metric. Now the secondary metric for the projects are usually the numerical representations of the primary metrics. So for instance, it could be defects per unit or defects per million opportunities, the average age of our receivables, or the number of lines of error-free software code. Or it could be just also the reduction in the amount of scrap. Now, consequential metrics, they measure the negative effects of improving the primary or key metric. They are used to measure the indemnity triggered by any damage to the project. The inconsistent use of consequential metrics can also lead to a loss of opportunity and rework after a project ends. And then they also help to understand the cause and effect relationship between the primary and the secondary metrics, as well as the impact that they have to the organization. So let's go through an example of a consequential metrics. Now in this particular scenario, a project is carried out to increase the pace of introducing offers to customers. But in the current practice, releasing the offers at a faster pace will hamper the quality of the previous offer. So due to the current offer, the product will be degraded as overpriced, or it can degrade the project margin from the incoming offer, and it will be underpriced. So what's our solution? Well, instead of increasing the pace of introducing offers and calling it as an improvement to the process, the team can create and introduce a new design or modify the process to benefit the organization. By increasing the pace of introducing offers, the project can show that the profit is made, but it also fails to record the loss and downfall of the previous offers. This is where consequential metrics help to understand the cause and effect relationship between the primary and the secondary metrics, as well as its impact on the organization. So here are some best practices when we look at consequential metrics. First, let's set consequential metrics during the measure phase and monitor these metrics after finalizing the project. This will help to analyze whether the link between the previous primary and the secondary metrics has been established. We can also link consequential metrics with primary metrics, and finally linking them to the secondary metrics proactively on the impact of these metrics. And then the third one is assessing and evaluating the cause and effect relationship between these metrics is also helpful to the organization as a whole. Now, the project manager uses various tools to plan and control the project. Some of those prominent project planning tools would be the Pareto Chart, the critical path method, the program evaluation and review technique, or PERT, using Gantt charts, as well as a work breakdown structure, or WBS. Now, a Pareto chart is also known as the 80-20 rule, or the vital few to trivial many. It's a histogram that depicts the frequency of occurrence of events. It plots all of the causes for defects in a product or service. The values are represented in a descending order by bars, and a cumulative total is represented by a timeline. And a cumulative total is represented by the line. So 80% of the effects come from 20% of the causes. Thus, Pareto chart narrows the scope of our project or problem solving by identifying the major cause affecting our quality. So here's a great example of a Pareto chart. A hotel receives plenty of complaints from its customers, and the hotel manager wishes to identify the key areas of their complaints. So the first thing that he's going to do is he's going to number the type of complaints. And the types or causes of complaints that he gets is cleaning, check-in, pool timings, minibar, room service, or other. And he currently has 35 complaints in cleaning, 19 in check-in, 4 in pool timings, 3 in the minibar, 2 in room service, and 1 with other. So by calculating that, he has a total of 64 complaints that he's received at his hotel. Now, by just doing simple percentages, 54.69% of his complaints come from cleaning. 29.69% come from check-in. And when we add the 54.69 plus the 29.69, we get an cumulative total of 84.38%, and so forth and so on, until we have 100% accumulation. What a Pareto chart in this particular case is going to help the hotel manager is to realize where he needs to spend his resources so that he has less complaints, and thus a greater impact not only on the customer experience, but also on the quality of his product, which in this case are hotel rooms. So if he applied all of his resources to room service or to even the minibar, that would not have as a significant effect on experience and defects than applying it towards cleaning. He can solve 54.69% of his problems by just solving the cleaning problem. Now he can go back and do the 29.69% in the check-in problem, and he would have solved 84.38% of his problem. That's the power of Pareto charts. Now, a network diagram or an arrow diagram is a project planning tool that uses arrows to connect activities and represents precedence into interdependencies between activities of a project. Now, there are some assumptions that are made when we draw a network diagram. The first one is before a new activity begins, all pending activities must be completed. The direction of the arrow that represents the sequence of activities needs to be followed. And a network diagram must start from a single event and end with a single event. So in order for a network diagram to calculate the total duration of a project, the project manager needs to define 4 dates for each one of the tasks. It begins with identifying an early start, which is the earliest date by when the task can be started. The late start date would be the last date by which the task should be started. And then we have an early finish, which is the earliest date by when the task can be completed. And then finally, a late finish, which is the last date by when the task should be completed. Now, there are 2 more terms that we need to understand when it comes to network diagrams. The first one is a duration of task, which is just the difference between an early start and an early finish. Then we have slack time, or some people call it float time for a task, which is the amount of time the task can be delayed before it causes a delay in the overall project timeline. Now, critical path method, or CPM, is a project planning tool used to monitor the progress of a project and to ensure that the project is on schedule. It is always considered the longest sequence of tasks on the network diagram. Now in this particular graphic, we can see that the critical path is the network diagram that is highlighted in orange. Now the tasks on the critical path have zero slack, and the resources from the tasks that are not on the critical path can be diverted to tasks on the critical path to ensure that the project is not delayed. And then finally, a complex project can have multiple critical paths. So the project evaluation and timeline technique, or PERT, is a form of a network diagram used for identifying the critical path for the project. Now this technique was developed to simplify the planning and scheduling of a complex project and create a more realistic estimate on the duration of each activity. Now PERT will use three kinds of estimates for the duration of each activity. It's going to use something called the optimistic estimate, which is where we expect all the factors that affect the activity to go in favor of the activity and is therefore slightly less than other estimates. Then we're going to have the most likely estimate, which assumes that the activity will encounter some issue during execution and hence provides for some contingency buffers in the estimate. And then finally, we have the pessimistic estimate, which assumes whatever can go wrong will go wrong and will include large contingency buffers, which is the highest among all three estimates. Typically, when we do a project evaluation using the PERT technique, I would recommend the most likely estimate. But you do have to plan for the most optimistic estimate, which is assuming that everything will go right, and also for the pessimistic estimate, which assumes that everything will go wrong. Now, the Gantt chart provides a graphic method to schedule, plan, and control a project and record progress towards completion of various activities within the project. Primarily used in a waterfall type of technique, the project schedule is represented as a bar chart spread over a timeline, so it's a horizontal bar. It will have the baseline, actually completed, remaining duration, and slack of the tasks are all indicated using a color length and color codes. Here's a good example of a Gantt chart. Now in this particular example, tasks A and B were completed on time. Task D is delayed by 1 day. And tasks B and C will start after completion of task A. Task F is dependent on task D, hence delay of task D will impact task F, and it will finish a day late. And then the tasks which do not have slack time, or tasks on the critical path, which are tasks B, D, and F, are tasks within the critical path on this Gantt chart.